In this video, we continue looking for the answer to that question about the root zone. How much water can it actually store? Last section you found out about how the soil works. Now, with that knowledge, we have to define what soil water content means to us. And to do that, we're going to use some simple soil water content concepts. Soil scientists use complex soil physical models representing the hydraulic potential components and hydraulic conductivity, which we discussed a little bit in previous video to estimate how the water flows into the soil. We, however, will follow a more pragmatic approach, which is actually better suited for our needs in the context of irrigation. We are going to define 4 different states of soil water content in the soil. That's relatively simple. Let us look at the 2 limiting states. Our upper storage limit is called the field capacity, FC, and our lower limit is called permanent wilting point, WP. FC is the maximum water storage that can be held in the soil. It is when the soil cannot receive any more water without draining it quite quickly. In soil science, it is often defined as the water content after 2 days of draining a very wet soil. Typically, coarse soils like sand will drain quickly to a relatively low field capacity, while much finer soils like clay will hold a lot more water. If you remember the previous video, we learned that this is due to the pore sizes in the different soils. WP, or wilting point, is the point at which the plant cannot longer extract water from the soil, and it will die. In other words, it is when the water is held in the small pores and that the roots cannot anymore overcome the very high soil water retention. Even if water is added to the root zone after we have reached that point, most crops will actually die. Therefore, we often speak about permanent wilting point. It means the crop has actually died. Of course, plants don't just suddenly die when the water becomes scarce. There is a critical point of water content at which they begin to experience stress. We note that as the point of critical water content, CW. This point is very much dependent on the crop. You have more sensitive, less sensitive crops, and on the reference evapotranspiration. Depending on the growth stage of the plants, stress can stunt crop yield development. The first 3 states of soil water content we defined or decided by the soil, the crop, and the atmospheric characteristics. With these in mind, the 4th point is the one at which the farmer actually waters the crop. We call it the management allowed deficit, MD, and very much it depends on the strategy of the farmer. MD could be equal to CW if the farmer wishes to irrigate just at the point before the stress occurs. It could also be before, if the farmer prefers to reduce any risk of stress. But of course, this will require a much higher irrigation frequency. or it might be even after that point if the farmer decides to allow some stress at some or all of the growing stages. Allowing stress is called deficit irrigation, and this is possibly a good strategy when the farmer has limited access to water. In any case, if the farmer is part of an irrigation scheme, the schedule in use will have a very large impact on the position of the management allowed deficit. We outlined the 4 states and what they represent. We now add the annotation theta to signify water content as a proportion to the total soil volume. Therefore, our 4 states of soil water content are theta FC, theta WP, theta CW, and theta MD. This gives us distinct storage capacities. The total water available for a crop, regardless stress or not, is theta WC minus theta WP. The easily accessible water, so to uptake without any stress, is theta WC minus theta CW. The actual available water at some stage for the crop just before irrigation is theta FC minus theta MD. We've now outlined the different states of soil water content. This is a bit simplified as concepts, but their sufficiency useful for irrigation. And we should remember they're dependent on soil, crop and atmospheric characteristics, as well as on management decisions by the farmer. It is very important to remember that the water is taken up by the roots under aerobic conditions. A major challenge for irrigation is to supply the water to the root zone in an efficient way.